now that we've drawn those beautiful triangles and squares and balances and had so much fun playing with all those pieces, now we actually got to do something that looks a little more traditional, something that you probably have seen before, and that you probably, if you had to ask your people at home that help you with math, they probably remember it. Hopefully this process and the way we approach it in this video will make things a little easier for you. Now going forward, if you want to keep drawing pictures, that's fine, but now there's a writing component with it. So whether you draw the pictures or use the traditional algorithm, so the traditional way that you've seen before and that we all know and love or hate, hopefully love, you must have justification to support your work. So you can use synonym and similar phrases as long as it's mathematically equal. So if I put something and you phrase it a different way, that's fine. We're not going to get picky about the wording, but what we are going to get picky about is it mathematically accurate? If you write the word sum and then you subtract and I put the word subtract, those aren't mathematically accurate because those are two different things. If I put sum and you put add, totally fine. Okay? Some things to keep in mind. Variables have got to be positive for the answer. So if you end up with a negative variable, that's not okay. What you'll have to do is, we'll get into that in a minute. That's kind of the same as getting the star in the hands-on equations. Our goal is to always solve for x. Okay? Always solve for x. Now, when it comes to justifying, the first thing that I'm going to ask you to do is state the objective, meaning get the variable by itself. That's all you have to write. See that? I even wrote it out for you. So step 1 to justifying, get the variable by itself. Step 2 is distribute. Now notice that before it says distribute, it says if necessary. You're not always going to have to, but if you do have to, that's when it comes into play. Next, it's form a zero pair. Okay, and we do that if we are adding or subtracting with the variable. So again, it's only if you are doing it. Then the next step is if you're multiplying or dividing with the variable, you do the inverse. Then you get your answer, and then you check using PEMDAS. So notice that I have highlighted 6 phrases. Those are the phrases that are going to come into play with the justification. So notice those are words. So we're not just going to be writing numbers and just drawing pictures. We're going to be writing words. And if you've gone ahead and underlined them, great. If you've not gone ahead and underlined them, please do so now. Pause the video and underline if you need to and haven't done so already. This is meant to be a reference tool for you while you are justifying. So you can kind of come back to here and jog your memory. Again, you will not always have steps 2, 3, and 4 in every problem. Okay? The other thing I'm going to tell you is I was kind enough to type this all out for you. Pretty awesome of me. Meaning in our examples today, you're going to hear me typing. Because to be honest, I've already written it once and typed it out here. For me to write it in again, nope, not going to happen. I'm going to save myself a little bit of time and I'm going to type. Sorry that I get that. But y'all can just deal. It's cool. All right, starting with our first type of equations with integers and decimals. So let's just take a look at number 1. Notice this beautiful little chart? If you were to set it up this way, totally fine. Now, the first thing I want to draw your attention to is that where the first box, this is your example. Okay? And then you really won't use anything below. If you come across notes or you want to write things in there, feel free. But those things below that are just there for you. This second column is going to be where you show all your steps. Now, I've divided it into things because it's a chart and I did it on the computer, but you don't necessarily have to draw yours into those steps. The last thing is where you're going to justify, and that's where the words are going to come into play, the things that we underlined previously. So looking at this first problem, it says n plus negative 3 equals negative 7. So the first thing I did was I wrote the problem in the work column. And the justification for this is to get the variable by itself. Goal, get n by itself. Seems really silly to write that, but the purpose of that is to draw your attention to it. So again, if you are drawing this on paper and you don't want to worry about that first column, the example column, don't worry about it. It's the second and the third column that are the important ones. Now next, what did I do? The goal is to get n by itself. So the first step to getting n by itself, or the next step, is to make a zero pair with -3. Since we had plus -3, make it a little bigger for you. Since we had a plus -3, to make a zero pair, it would be minus -3, right? If I have a -3 and I take it away, that's going to be a 0. So this is where our zero pair comes in. And I wrote, make a zero pair with -3. I didn't just write that I was making a zero pair, I told what I was making a zero pair with. Okay? So next comes in -7 minus -3. We know that if I have 7 negatives, and if you need to draw it out, that's fine. If I have seven negatives, 2, 3, 4, 5, 6, 7, and I come in and I take away 3 of them, 1, 2, 3, I'm left with 4 negatives, so our answer is -4. Or you can go through the process of add the opposite. But again, now you see why you need to know those order of operations. Next is to say, what's my answer? My answer is n equals -4. Now it wants me to check using PEMDAS. So we've got to use order of operations, and you have to know your integer rules. So where the -4 was, I filled it into the original equation, all the way at the top. And I get -4 plus -3. That does equal -7. All right, now, that's kind of to familiarize yourself with this process. Hopefully this all makes sense, and that this makes it a little easier for you guys. I'm going to try. So looking at the next one, our example is k minus 13.8 equals -16.4. First thing we're going to write is that our goal is get k by itself. We want the variable by itself. That's what we're shooting for. Now, the next step, what did I do in that second step? What did I do? Notice that I've done all the math for you. So what you are doing is merely practicing with your justifications, because this is the step that students often have the most trouble with in 7th grade. Our thought process is, hey, last year you learned how to solve one-step equations. This year you've learned how to do adding, subtracting, multiplying, and dividing with fractions, decimals, and fractions and decimals and negatives. So therefore, you already have that mastered. So the focus of these notes is work just on the justification, because that's really the newest piece to this. So what we did next was we made a zero pair with 13.8. How did we do that? We saw that it was minus 13.8, so we added 13.8. Then we said -16.4 plus 13.8. Knowing our integer rules, the signs were different, so we subtracted to get our answer. And we had more negatives. 16.4, it had the bigger absolute value to tell us that our answer would be negative. And then the final step is we actually got to use our order of operations and check to get our answer. And see, does -2.6 minus 13.8 equal -16.4? Yes, it does. If you were to actually go through the process of checking it, you'd find out it works. So if I, on a test, or your teacher on a test gave you k minus 13.8 equals -16.4, solve for k, your expectation is that you're going to be able to set up the other two columns. Notice that the justification phrasing, it's not too much, but also it's very similar to what you underlined on the first page, or underlined on the previous page. Now let's take a look at this one. This is a multiplication problem. Okay, so our goal, again, is to get w by itself. Pretty straightforward. Then, in order to do that, when we look at 3 and w, we note that that means multiplication. So we have to do the inverse of multiplication, because inverse means opposite. If you need to also add in the word divide, that's fine. But the important thing to note is that the reason we're dividing, don't just put divide, okay? The reason we're dividing is because it's the inverse of multiplication. So I'm not just writing out my steps, I'm writing out kind of the whys behind it. Then we get our answer, and we're able to check it using PEMDAS. And if you actually multiply out -26.5 times 3, we know it's going to be negative because the signs are different, and it does in fact equal 73.5. Okay, looking on to the next example. -t divided by 6.1 equals 8. Step number 1, of course, is the goal is to get t by itself. And then how would we get t by itself? Well, we have to do the inverse. We have to look and see what are we doing between t and the 6.1. Well, we're dividing. So we do the inverse of division. And that means that we have to do multiplication. So we multiply 8 times 6.1, and that gives us positive 48.8. The problem is the variable, or t, is not by itself. That's an issue, because we just said, very first thing we wrote for our reasoning was the goal is to get it by itself. In order to do that, t is not by itself. We found the opposite. So that means that if negative t is 48, that means positive t is going to be negative 48. Okay, so we found the opposite. So you can think of it as that negative t is positive 48.8. So positive t is the opposite. That kind of makes sense. And then we got the answer, and we checked it using PEMDAS, because we use order of operations to check everything. So just like when we were finding star, and we'd find star, so we had to find x when we did hands-on equations. In this case, we found a negative t, so we had to go and do the positive version. All right, the final page for decimals and integers. Here we have a two-step equation because there's two operations in it. And the reason we say there's two operations is that you have 4 times m, so that's multiplication, which is 1, minus 9. That's the second operation, making this a two-step equation. Everything else has been a one-step equation because there's only been one operation. So taking a look at this, let's go through our checklist that we went over on a couple pages ago. Again, the goal, get w by itself. We write that down to keep our mind focused on what we're doing. And that's a major typo because in this case, the variable is m, not w. So if you can go ahead and make that correction. Okay, that our goal is to get m by itself, not w. Now, in order to do that, we're going to make a 0 pair with 9. So how do we make a 0 pair with 9? Well, since we said minus 9, to make a 0 pair, we got to add 9. And we end up with negative 17 plus 9. Signs are different, so we subtract, and we have more negatives. The 17 is the larger absolute value, making it negative 8. Then we did the inverse of multiplication, which in this case is division, is division, and we have negative 8 divided by 4. Notice that in all the cases when we've divided, that the number with the variable has gone second. So negative 8 divided by 4. Our signs are different, our answer is negative, and our answer gives us negative 2. We check it using PEMDAS. So here, it's not a quick check on order of operations. You actually got to do, it's not just like a one thing, got to do both operations. So first I multiplied 4 times negative 2, and that's where negative 8 came from. Negative 8 minus 9 does equal negative 17. Okay, on to example 6. We know that our goal is to get, in this case, x by itself. First step and the last two are usually the easiest to justify. Moving into the next step, what do you do? So if we go through our checklist, we don't have to distribute. We have to make a 0 pair. But we don't just write make a 0 pair. We make a 0 pair with negative 7.43. And that means that since the equation said minus negative, we have to do the opposite, and we're going to add a negative. Negative 20.86 plus negative 7.43 or 43. Signs are the same, so we can add and keep the sign, and that's where we get the negative 28.29 from. Negative 28.29. Then we have to say, hey, what's our next step? Well, we have to do the inverse of multiplication, which is why we've divided negative 28.29 divided by 3.45, because division is the inverse of multiplication. And that is how we get our answer of negative 8.2. We know it's going to be negative because our signs are different. Then we can check it using order of operations, or PEMDAS. And we know it's going to be, we know we had to have 2 steps at least when we checked our answer, because it's a 2-step equation. We know it's a 2-step equation because from the very beginning of the problem, we can identify 2 operations in this equation. However many steps are in the equation, however many operations are in the equation at the beginning is going to be a good indicator of the minimum number of steps you need when you check your answer to see, does it make sense? Does it work? Are both sides equal to the same amount?